Exercise 8C. This is where we look at exponential functions again, now with real life situations, data, scenarios that you may come across in an exam type question. This would be called modelling, I suppose. And one thing we're often expected to know and understand is this thing we've touched on before, this idea that when you find the gradient of a exponential function, it's very, very much linked to the gradient of the original function. In fact, we said last time that if y equals e to the x, then the gradient, now bear in mind I did actually call it dy by dx last time, but I didn't really dwell on it too long. This is just a way of writing the gradient function, and you'll see this in chapter 8 from memory. No, it can't be chapter 8. Chapter 12 this comes up. Chapter 13 maybe even. But when you do it in chapter 13, then this becomes quite an important idea. Differentiation it's called. But for now we're just going to understand that this thing means the gradient function, this dy by dx. And if you start with y equals e to the x, dy by dx is also e to the x. Now we went a bit further. We said that if it was a slightly different function, y equals some e to the kx, well k was always a number like 2.6 or 9.2 or something, then you could find the gradient function, dy by dx as we're now calling it, and you knew it was k e to the kx. Interestingly, that k came to the front, but the k didn't change here, the power stayed the same. Now bear that in mind, because now we're going to have real equations. For instance, here's one of them. This is n equals, so n might be the number of people in a room as a concert starts, or something like this, or it might be the number of radioactive particles in a piece of plutonium. So n then it stands very often for number of whatever we're counting, and we've got an equation ae to the bt. Now if I therefore find dn by dt, notice the x is changed for a t, but other than that it's the same idea. If we find the gradient function, then notice it's become, now the t stays the same, so that's no different. Now the b, if you remember, gets times by the front, so that's why we've got ab, and then e to the bt, this bit doesn't change. The b just moves to the front and then is retained as a power. And so this is the formula I want you to learn. Again, it's a reminder of the old formula. Gradient of e to the t is e to the t. The gradient of ae to the bt is a times b e to the bt. So get your head round these ideas. So here's our question. Example, the equation below gives the number x of bacteria in a solution. It sounds like COVID all over again, doesn't it? And presumably this bacteria over time increases. And it says how many bacteria are there after 2 hours. Well, first of all, we've got an equation. We can just use this equation to work out how many there will be at any time. So after 2 hours, t will be 2. So here all I'm going to do is I'm going to do x equals 200 times by e to the 0.53 times 2. I'm going to type that into my calculator. Let's see what it says. What is it? 200. Notice I'm not finding the gradient of it. It doesn't ask me to do it. It just says how many will there be. Times by e to the 0.53 times 2. And I get 577. So on this first answer, part 1, I get 577. Now it's actually 577.27 ... It goes on for a long way. I can't write that, so I'm just going to write to 3 sig figs 577 bacteria. There we go. What's the rate of increase? Look, whenever you see this word rate of decrease or increase or growth or whatever it is, but look out for the word rate, because that tells you you're finding the gradient. So part 2, I'm going to find dx by dt. I'm going to find the gradient, and that basically means I'm going to bring that 0.53 to the front, so it will be 200 times by the 0.53 e, and you remember the power doesn't change, it's still 0.53 t. So if I do 200 times 0.53, You can obviously do it very quickly, but just to confirm, I've done it on the calculator, and it says 106 e to the 0.53t. Now that's the gradient at any point, but it wants the rate of increase, or the gradient, after 2 hours. So I can just write when x equals 2 dx by dt, and I can just sub 2 into this. So it's 106 e to the 0.53 times 2. So I'll type this into a calculator, 106 times e to the 0.53 times 2. And I get 305. 0.96, I suppose. So I'm going to call it 306 to 3 sig figs again. So that's 306. Part 3. How long does it take for the bacteria to reach a count of 1,000? Alright, now that's solving an equation. Let's see on the next page. Well, let's see what it was. It was 200 e to the 0.53. 200 e to the 0.53. This is how many bacteria, I hope, don't want that, e to 0.53 t, how many bacteria I have at any one time. And it says, when will it equal 1,000? So I just set this equation equal to 1,000, equals 1,000. And I now have to solve this equation. Move the 200 over. That's e to the 0.53t equals 1,000 divided by 200. Well, that's quite easy to do in your head. 0.53t there equals 5. And now I have to move the e onto the other side. And when you move the e onto the other side, it becomes a natural log. So natural log of 5. E hasn't got its, don't have to write it in a log notation, just write this ln. So does it want, it probably wants proper decimal answer here, so I get 1.6 for this. 0.53t equals 1.609 and a bit. So t equals, I'm going to just divide that by 0.53. I get 3.04. Now this is, was it hours? I think it was. Yes, it was hours. So that's what I reckon. Let's see what the answers say. Well, I've got the last bit right. 306 and 577. 306 and 577. So yes, I've got all three right. Good. Example. The number of fish in a pond is given approximately by this equation. Okay, so I've got this where n is the number of fish, presumably, and t is the number of months. Now, it's got a negative power, so you might recall what happens to that. Anyway, so it's how many fish were originally in the pond. Well, originally sounds to me when t is 0. This is something initially is very often the way they will say it, but it's very common for them to give you a 1-mark question that says, yeah, how many were there originally? So t equals 0, so that means n equals 50 e to the minus 0.05 times 0. Now, anything times 0 is 0. So this is 50 e to the 0. And of course, anything to the 0 as a power is 1. So this is actually, that first number is more important than you'd imagine. There are 50 fish originally. How many fish were there after 1 year? Now, of course, this was in months. 1 year sounds like 12 months. So I just think I need to do this. So when t is 12, of course, when t is 12, is now n is 50 e to the minus 0.05 times 12. So it's just a case of typing it in. Not quite so pretty answers last time, so I shall do it all on my calculator. Negative 0.05 times by, what was it, 12? I've got 27. 27.4. So, I mean, I'm going to write 27.4, but presumably you can't get 27.4 fish. So presumably that's really 27. But I shall write 27.4 for the sake of argument. Now, what's the rate? Now, we're going to have to remember what rate means. Whenever you see the word rate, that's when it tells you, really, it wants you to find the gradient. So we're going to do that. So let me write this equation down on the next slide. It's n equals 50 e to the minus 0.05 t. Let me just check that I've got that right. 50 e to, yes. And so I want dn. I'm going to find the gradient by dt. And I bring this down, it's 50 times by a negative 0.05 e, and then the power doesn't change, it stays the same. So if I do 50 times by that negative 0.05, it's obviously a nicer number, isn't it? It's minus 2.5 e to the minus 0.05 t. And that's the gradient, that's the rate. Now what did it want, when did it want to? Find it after 1 year. So after 1 year is t is 12. So therefore dn, the rate, is minus 2.5 e to the minus 0.05 times 12. So let's type it in. Times by e minus 2.5 times by e to the minus 0.05 times 12. And I get minus 1.37. Now that basically means we're losing just over one fish every month. I think that's what that's trying to show me. Let's see what I get. Oh yeah, I've written it to 1 dp. So we're losing about 1 per month. So that's basically what I'm saying. You're losing a fish a month after 1 year has passed. Presumably it was a bit steeper initially, so we might have been losing 2 a month initially. But so let's get our head into gear here regarding this the terminology. It says exponential growth and decay. Y equals AE to the BT. Now A represents the initial value. We saw that before. The number at the front is no accident. If B is bigger than 0, you get exponential growth. The graph will look like that. But if B is less than 0, you get exponential decay. The graph will look like that. And interestingly, it will cross at A in both situations. So we've got one last question to look at. It says, an OCR exam question, no less. The mass of a substance is decreasing exponentially. So already I know this is Y, well, it says the mass is in grams. So presumably it's M equals, well, it's going down. It was 200 initially, so that's straight away I can do that. M equals 200. E, because it's exponentially decreasing, I'm going to say e to the minus. Probably I need to write k, because I don't know what it is, kt. And that's the power I need to find. Now, I got the 200 because I saw that it said 0 and 200 initially. So that's why that was 200. To get this one, I can say t equals 5. So when t equals 5, I know that m is 160. So put those in. I say 160 equals 200 e to the minus k times by 5. Move the 200 over. I get 160 divided by the 200, which is 0.8, equals e to the minus 5k. Once I get this, I'm just going to now move that e onto the other side. I get minus 5k is the log of 0.8. I do the log of 0.8. The log of 0.8 is a negative 0.22, and if I divide that by negative 5, I get the k to be 0.04463. I'm going to write down. That's not very nice. But what it does, you see, it allows me now to write my equation as m equals 200 e to the minus 0.04463 t. I've got an equation. Brilliant. Now, I'm not going to be able to do the whole of this question. I think I'll run out of time, but I can certainly try to do these two parts here. It says, now find t, well, sorry, now find m when t is 10. So I can write m equals 200 times by e to the minus 0.04463 times by 10. If I type that into my calculator, I get 127.99. So I'll call it 128. So I know this is 128. I think we'll finish this in class. You've got to do one more prediction, which you might want to have a go at. And there's also saying, well, what happens when the mass is 50? How much time has elapsed? And we can have a look at that as well. So that'll do for now, and we'll finish this during the class. Thank you.